Hello everyone. In today's session, let us discuss about the second part of instruction set of 8086. Already we have discussed about the instruction set of 8086, and in the first part we have discussed about data transfer and copy instructions, the different from which location to based on from which location to which location the data has been transferred. It is categorized into many things. So all those instructions we have discussed. And today's lecture, let us discuss about arithmetic and logical instructions. So if you see the arithmetic and logical instructions, basically a microprocessor, it is a processor and its basic task is to perform arithmetic and logical operations. We know in general addition, subtraction, multiplication and division are arithmetic operations, and logical operations also we are aware of the logical gates and or not NAND. All these gates can also be executed using the arithmetic and logical instructions. So first let us discuss about the arithmetic instructions of 86. The basic instruction is add ADD, which is used to add two datas, so two operands. So see here again the syntax is being given. The operand can be an immediate data and a register. Operands can be two registers. Operands can be a source index register and a register. Operands can be a memory address. So any kind, the operands can be either immediate addressing, it can be register addressing, it can be index addressing, it can be indirect addressing. Direct addressing, so indirect addressing, so any kind of addressing modes can be used to perform addition operation. Then this is a normal addition without any carry. Then we have another instruction, add with carry. If the data what we are giving is a large data, that is if it has carry, then we can use the command ADC. If we are not using this ADC and if you are using ADD, then we'll be using counter registers to increment the carry separately. So rather than that, using ADC will be a good choice. The syntax for ADC was also been mentioned here. Then we have the subtract. Similar to the add, we have subtract, that is normal subtract. So when we see an addition, we have two outputs. One is sum and carry. When we see subtraction, we have two outputs. One is difference and another one is borrow. So a normal subtraction wherein so difference will be, borrow will be calculated separately, as like how carry can be calculated using some counter registers. Rather than that, we can have simple instruction like SBB in order to perform borrow with the same instruction itself. So this is subtract and subtract with borrow. Then other commonly used arithmetic instructions are increment and decrement, which is normally used to increment by 1. Right? If simply increment AX is given, the contents of AX will be added by 1. Then we have the negate and compare instructions. So negate is used to find the complement of a number. So what is complement of a number? If a binary number is given, the means 2's complement. If a binary number is given, find the ones complement of that. That is ones and zeros will be inverted. Find the ones complement of that. Then add 1 with the ones complement in order to get 2's complement. So this is defined as negate. So if we want to find 2's complement of a specific number, then we can use the instruction NEG. Then CMP, it is used to compare two data, that is data and the source and the data and the destination will be compared with the help of compare instruction. Then we have the other arithmetic instructions, multiplication. In multiplication, two types are there. One is MUL and another one is IMUL. That is signed multiplication and unsigned multiplication. The syntaxes were also given. Other than this, we have the to increase the values, that is to convert a byte to word, to convert a signed word to double word, sign word to double word. So what is a word? 32 bits is a word, right? So for this conversions, we have certain instructions like CBW and CWD. Then we have division. So division, if you see this multiplication and division, will be having only one operand. See, even in multiplication, if you see, only BH was given, not source and destination was not been given separately, because for this multiplication and division automatically will assume A as the other register, the destination register, and also the other register where the operand will be. So accumulator will be the other default register where the data where the second data has to be taken from, as well as the data has to be stored into. So multiplication and division has this principle. Similarly, division also you'll be having um, CL and CX only. We have then next to that we have the triple A instruction, which is ASCII adjust after addition. For every values, we have the ASCII values. We know in order to find the ASCII values, we'll be using triple A function. Then ASCII value after subtraction, the AAS. Then ASCII value after performing a normal multiplication will be it will return an ASCII value related to that hexadecimal value, that is AM. Similarly, we have AAD. And another instruction is to adjust the decimals. So it converts the result of packed BCD numbers into valid BCD numbers. So for that we have a DAA and DAS for addition and subtraction respectively. Then we have the logical instructions. Those are simple instructions which we use as AND. The two operands has to be mentioned, and then or. Similarly, for not always we'll be having one input, so only one input is being given. XOR, or for all those things. Then test instruction, it is a logical compare instruction. The test instruction performs a bit by bit logical AND operation on the two operands. So the result of this AND operation is not available for further use, but it affects the flag. So in order to test this, we'll be having. Similarly, we have certain instruction for shifting also. We have shift right and shift left. These are the two instructions in order to shift the bits we have. Then we have the rotate instructions also, rotate right and rotate left instructions. Suppose if it is a shift instruction, the if we are shifting to the right, the leftmost bit will lose. But if it is a rotate instruction, the rightmost bit will become the leftmost bit will move to the one place ahead, and the rightmost LSB will again take the MSB position. That is the difference between shift and rotate. Then we have rotate to left along with the carry flag. Similarly, rotate to right along with the carry flag. And this is for your assessment. Find, I have given two puzzles to find the value after performing the operation, right? And this is another puzzle for your to improve your knowledge. Thank you.